On to example 12, where things get a little bit more complicated. Here we're trying to derive the fraction 5 over the quantity x squared plus 1 all raised to the 30th power. Okay, how do we handle this? Because we have a fraction that we have to deal with. We have our outside function, which appears to be in the denominator of something. It is not as simple as just deriving the denominator by itself. We have to manipulate this thing a little bit algebraically before we can proceed with this. So when you have stuff in the denominator for a chain rule problem, or actually for any derivative problem really, if you don't want to use the quotient rule, what you want to do is bring everything up to the numerator and negate the exponent. All right, so looking at this here, I have this 30 in exponent in the denominator. I want to bring everything up to the numerator because that's what I know how to work with in terms of the power rule. So carrying along my ddx, I'm going to have 5 times x squared plus 1 raised to the minus 30th. Okay? The reason I did that is because now my power rule can be used. All right? So now let's identify an outside function. Outside function is going to be 5 parentheses to the minus 30th. The inside function is, again, the thing on the inside of the parentheses. So inside function is x squared plus 1. And then we can go and do the derivative from that. All right, so derive the outside function. This gives you minus 30 times 5, because you're bringing the exponent down in front. And then you subtract 1 from the exponent. So that does not give you minus 29. It gives you minus 31. Okay, you're subtracting 1 every single time. It doesn't just mean that the power, the numerical value of the power gets reduced. You're just subtracting 1. Just do it mindlessly, and you'll get it right, okay? Copy paste the original inside. And then finally, you multiply by the derivative of the inside, which is just 2x. Okay? So you've effectively derived it at this point. There's nothing more you really need to do unless it asks you to simplify. So this is the derivative. Let's simplify this. Okay, so let's combine this. That becomes minus 150, but we also have this 2 being multiplied here. Everything here in sight is being multiplied. So you can combine all your stuff that's being multiplied. So you have minus 300 times x squared plus 1 to the minus 31st times x. All right, so all I did was just combine the numerical factors here and multiplied those out. That's all I did. All right, now we have this negative exponent that we need to deal with. Negative exponent means it's in the wrong part of the fraction. So we're going to move it back down to the denominator where it belongs. So this gives us minus 300 x over x squared plus 1 to the positive 31st power, because now it's in the right part of the fraction where it belongs. All right? So with that, that is completely simplified. Nothing more we can do. Looks pretty. Good solid answer. And we're done with that. Again, the thing that made this challenging is that we started with something in the denominator, stuff with x's in the denominator. Move it up to the numerator by negating the exponent, derive as you normally would. Nothing terribly difficult about that. Just practice it and you'll get it. So that's example 12.